An optimization problem for you. Professor Russell Wilson, by the way. It is given sine y equals sine x. Find the local maximum, local minimums on the interval between 0 and 2 pi, and determine if the concavity is concave up or concave down. You can see from the graph here that the optimization for a sine is a maximum at pi over 2 and a minimum at 3 pi over 2 on the interval between 0 and 2 pi. But suppose we didn't have the graph here. How do you do it? Well, you do the second derivative test, actually. And here that is. F of x equals sine x, same thing as y equals sine x. F prime x, first derivative of sine is cosine. To find the critical numbers, set the cosine x equal to 0. And cosine is 0 at pi over 2 and 3 pi over 2. So therefore, pi over 2 and 3 pi over 2 are your critical numbers. Now, to find the concavity, and by the way, pi over 2, 3 over 2 is the optimization, but let's find the concavity to see what direction they are going. So to find the concavity, you do the second derivative. First derivative of sine is cosine. Second derivative of sine is negative sine. Put the critical numbers into the second derivative. And by the second derivative test, we have f prime prime pi over 2 is negative sine pi over 2. Since sine pi over 2 is 1, negative sine pi over 2 is negative 1, which is less than 0, what makes that concave down. And finally, f prime prime 3 pi over 2, since sine 3 pi over 2 is negative 1, negative sine 3 over 2 is negative 1, which is positive 1, which means at 3 pi over 2, the graph is concave up. And sure enough, here at pi over 2, the graph is concave down. And here at 3 pi over 2, the graph is concave up. So therefore, the optimization for the graph sine x is maximum, by the way, concave down to pi over 2, and a minimum concave up at 3 pi over 2.